Hello students. The topic for today that we'll be discussing is radioactivity. So what is radioactivity? As we have already discussed before and probably you have studied in your higher secondary classes, this is a phenomenon which is exhibited by certain nuclei, or it's a phenomenon which is exhibited by the nucleus of certain elements. It's not that all the nuclei they exhibit this phenomenon of radioactivity. Rather, naturally it has been observed that nuclei of heavier elements usually they are unstable and they try to attain stability by giving off the excess energy. In the process, they emit particles and radiations spontaneously. This phenomenon of spontaneous emission of particles and radiation from the nuclei of certain elements is known as radioactivity. So as I told you, it's a spontaneous process. It's a spontaneous process and it is a nuclear phenomenon. So these are 2 points that you need to remember, that the phenomenon of radioactivity is a spontaneous process and it's a nuclear phenomenon. It is exhibited by the nucleus of elements. So this process of radioactivity or the phenomenon of radioactivity was discovered by a scientist named Henry Becquerel in the year 1896. Rather, this was an accidental discovery when he realized that salts, a uranium salt, it emitted certain radiations which affected photographic plates. So this discovery was accidental in nature, but then after its discovery, the other scientists they took over, and even Becquerel, he did a lot of studies on this phenomenon of radioactivity. What happens during this phenomenon? What are the kind of particles or radiations that are being emitted in the process? So let us say that we have a source of radioactive element. Usually we keep it in lead boxes. Suppose a simple experiment can be done where we keep a source of a radioactive substance in a lead box. This is a source. So this radioactive element or the source of radioactivity will emit particles and radiations. They will be emitted in this direction. We have this kind of a structure so that the particles and radiations are emitted in one particular direction. Then we subject these radiations being emitted by the source to an electric field. You allow the particles or the radiation and the radiations emitted from this radioactive substance to pass through an electric field, positively charged plate and the negatively charged plate. So what was observed was that during this process of radioactivity, a radioactive substance can emit 3 kinds of particles or radiations. So one which is deflected towards the positively charged plate, one which is deflected towards the negatively charged plate, and one which is not affected by the electric field. So what can be done? We can put a detector here, or we can put a photographic plate here. Let us say we put a photographic plate here. So what was observed is that some of the particles and radiations they just go directly and strike the photographic plate. They don't suffer any deflection. Then, secondly, it was observed that some of them they are attracted by the negatively charged plate and they get deflected and they strike the photographic plate. The other third kind, they are deflected by the positively charged plate and they come and strike the photographic plate. So it simply means that during the process of radioactivity, 3 kinds of particles and radiations are emitted. So the first kind are the positively charged, second the negatively charged, and third, the neutral or uncharged. So now we know that these positively charged particles, these are particles which are emitted from a radiative source, we call it the alpha particles. Then the negatively charged, we call it the beta particles, and these are gamma. These are the gamma rays. So these are the three kinds of particles and radiations that are emitted by the photographic plate, by the radiative source. And they leave its impression on the photographic plate, and you can see here. And here you can see that the positively charged particles, so which the ones attracted by the negatively charged plate will be the positively charged ones, the alpha particles. These are the negatively charged ones, the beta particles. So you can see that the amount of deviation of the negatively charged particles are more than that of the positively charged particles. So this simply means that the positively charged particles are more massive compared to the negatively charged particles. So as we have discussed, there are three types of emissions during the phenomenon of radioactivity. Three kinds of particles and radiations are emitted. So first one, these are the alpha particles. These are the alpha particles. The second, the beta particles. And the third, these are the gamma radiations. So after the discovery of radioactivity, a lot of analysis was done to study the properties of these alpha, beta, and gamma. So it was found that these alpha particles are nothing but a doubly ionized helium atom. Means this is a helium nucleus. These are nothing but helium nuclei which are being emitted from the nucleus of radioactive elements. Beta particles are nothing but these are streams of electrons, negatively charged electrons, and gamma rays, these are energetic photons that are being emitted from the radioactive substance. So the properties of these particles and radiations, this is not there in this part of the syllabus, but still we can revise that. These alpha particles are positively charged. They are doubly ionized helium atom, means these are helium nuclei. They have two protons and two neutrons inside them. They are affected by electric and magnetic fields. They possess high ionization power. Means as they pass through a gas or some, it causes ionization. It kicks off electrons from the atomic orbitals. They can cause ionization, and of course they can pass through matter. They have penetrating power. But as because they are massive compared to the electrons, that is the beta particles, their penetration power is lesser than that of the beta particles. And these beta particles, as I told you, these are negatively charged electrons. So compared to the alpha particles, they are very, very tiny. As a result of which, their penetration power is more, but then their ionization capability, the amount of ionization that they can cause as they pass through a gas is less than that of the alpha particles. So these are the two things that you need to understand. Primary difference between the alpha and the beta is that difference is in their charges. One is negative, the other is positive. Alpha particles higher ionization power, beta particles lesser ionization power. But alpha particles lesser penetration power compared to the beta particles. And both of them, they are affected by electric and magnetic fields, as because they are charged particles, and also they can affect photographic plates. They can leave their impressions on photographic plates. These gamma radiations, as we have already talked about, these are nothing but energetic photons which are being emitted from radioactive nuclei. So as a result of which, they are not charged. So they have high penetration power, and they are not affected by electric and magnetic fields. And in almost all these series, rather there are 4 naturally occurring radioactive series. uranium, thorium, actinium, and neptunium. It starts with these elements, and in all these four radioactive series, the final nuclei that we get is that of lead. Lead is very stable, so lead is the end product in different isotopes of lead. Also, when we talk about radioactivity, we have to remember that it is classified into two types. One is which one we call the natural radioactivity, and the other which is radioactivity, artificial or induced radioactivity. So, what is natural radioactivity? It's the phenomenon of radioactivity which is exhibited by nuclei which are naturally unstable. Usually, this is found in heavier elements in nature having mass number greater than 206. So these elements, they exhibit the process of phenomenon of radioactivity naturally. They are naturally unstable. On the other hand, artificial radioactivity is a kind of radioactivity which is exhibited, it's a phenomenon exhibited by elements, nuclei of elements, which has been made unstable artificially. So, stable elements can be made artificially radioactive by bombarding them with energetic particles and radiations. So in this process, we can convert naturally occurring stable nuclei into radioactive isotopes by bombarding them with energetic particles and radiations. So as because radioactivity is a natural phenomenon, it has to obey certain laws. Any process or any phenomenon that occurs in nature, it is governed by certain laws. Hence, the next thing that we'll discuss is the laws of radioactivity. So, these laws of radioactivity can be broadly classified under two headings. One is the laws of radiative displacement, the laws of radiative displacement, and the laws of radiative displacement, and number two, the laws of radiative disintegration. Disintegration. So, the laws governing the phenomenon of radioactivity can be classified broadly under these two headings. First, let's discuss what is law of radiative displacement. So, displacement here means the displacement in the position of the element in the radioactive table. That's why we call it the laws of radiative displacement. When a radioactive nuclei or an element, it emits alpha and beta particles, their position in the periodic table displaces. Why? Because their atomic number changes in the process of radioactivity, or the mass number they change. That's why we call it the laws of radiative displacement. So first, let us consider the alpha decay process, alpha decay or alpha emission process from a nuclei. So we also call the phenomenon of radioactivity as the process of spontaneous disintegration of the nuclei of elements. Let us suppose we have a nucleus of an element in the form AXZ. Here X is the symbol of the element, A is the mass number, that is the total number of protons and neutrons inside the nucleus, and Z is the atomic number, the total number of protons. So if this nucleus, it undergoes alpha decay, that is, it emits an alpha particle. If it emits an alpha particle, so what will happen here is the mass number of the element, it reduces by 4. So the element it changes and the atomic number it reduces by 2. So plus the alpha particle. So alpha is nothing but 4He2. So in the process of alpha disintegration or in the process of emission of an alpha particle from a radioactive nuclei, the atomic number it decreases by 2. That means the element displaces 2 places in the radioactive table, in the periodic table, sorry. The element, it displaces 2 places in the periodic table. That's why we call it the law of radiative displacement. Second, we consider the beta decay process or the process of beta emission. In this process, what happens? Again, let us say I have a nucleus AXZ. If it undergoes the phenomenon of beta decay, what happens? The mass number, in this case, it remains the same, but the atomic number, it increases by 1, plus the beta particle emission. So beta nothing but the electron. So this is something which is very interesting. Later when we go and study about higher nuclear physics, we'll study more about it. How a nucleus which has only protons and neutrons emits an electron. So in this process, what basically happens is that a kind of disintegration occurs within the nucleus in which a neutron, it converts itself into a proton with the emission of an electron. Hence, the mass number remains the same because a neutron is getting converted into a proton. So the sum total of the number of neutrons and protons remain the same, whereas the number of proton, it increases by 1. So when a nucleus undergoes the phenomenon of beta decay or it emits a beta particle, the element in the periodic table, it displaces 1 place forward. So this is what is called the law of radiative displacement. During the emission of gamma, nothing happens. It's just that the nucleus of an element is in an excited state and it gives off its excess energy by emitting or giving off the excess energy in the form of gamma radiations. Next, we discuss the laws of radiative disintegration. So, this can be put under the following points. Number 1, it states that the phenomenon of radioactivity is a characteristic of the element exhibiting it. That means it is a characteristic of the element exhibiting this phenomenon. What we mean by that is that different radioactive elements will exhibit different kinds of radioactive decay, difference being in the type of emission and rate of emission and the energy of emission. So it is characteristic of the element. So the type of emission, the rate of emission and the energy of emission. So this is characteristic of the element exhibiting this phenomenon. It is not uniform across all the elements. That is what is meant by the first point of the laws of radiative disintegration. The phenomenon of radioactivity is a characteristic of the element exhibiting this phenomenon or the radioactive element. It differs from element to element. Secondly, the phenomenon of radioactivity is a spontaneous process. Spontaneous process. Spontaneous in the sense it is not affected by external factors. It is a nuclear phenomenon. It will happen spontaneously. And you can't change this phenomenon of radioactivity by changing the external parameters like temperature, pressure, etc. You can't influence it from outside. It is a characteristic of the element. If it emits some kind of particles, it will keep on emitting till the nucleus it disintegrates to a stable form. And hence it is a spontaneous process. Also, the disintegration, number 3, is random. This is a random process. Random in the sense if I have a lump of radioactive element, which nucleus will undergo disintegration first? It is random. Nothing determines that. You can't predict which nuclei will undergo disintegration first. The most important law of radiative disintegration is that, you can put it as number 3 or number 4, if I am not wrong, that the rate of disintegration means the rate at which the nuclei of the element is disintegrating, or the rate of emission of the particles and radiations, the rate of disintegration of a radioactive substance at any point of time is directly proportional to the number of atoms of the radioactive element present at that instant of time. Again, I am repeating, the rate of disintegration of a radioactive substance at any instant of time is directly proportional to the number of atoms of the radioactive substance present at that instant of time. So this is actually the law of radioactive disintegration. Let's do a mathematical deduction for that. Let us say that we have a radioactive element which has n atoms, at an instant of time t. Let us say that we have a radioactive element which has n atoms at an instant of time t. Let us say that dn atoms disintegrate in a time dt. So the rate of disintegration, where dt is very, very small, so the rate of disintegration of these radioactive elements at the instant of time t can be written as dn dt. So what this law of radiative disintegration states? It states that the rate of disintegration of the element at the instant of time t is proportional to the number of atoms of the element present at that instant. So as because it's a negative rate of change, means the number of atoms decrease with time. A number of atoms and hence nuclei, it decreases with time because they are undergoing disintegration. We put a negative sign over here. The negative rate of change is proportional to n. So dn dt minus dn dt is proportional to n, implies you can write minus dn dt is equal to lambda n, where lambda is called the disintegration constant. It's a constant, it's characteristic of the element, it's called the disintegration constant. It is different for different elements. So implies we can write this as dn by n, we can write it as equal to minus lambda dt. So integrating both sides implies natural log, we can put it as log e n is equal to minus of lambda t plus of c. So c is a constant which we have to find out from the initial conditions. Now let us say that the element has n0 atoms, or hence nuclei, at the initial point of time t0, or we'll put it as t is equal to 0 initially. Let n0 be the number of atoms which is there initially. So putting it back in this expression, therefore we have log E n0 is equal to minus of 0 plus of c, implies c is equal to log E n0. So putting this expression, putting the value of c back into this expression, we get therefore log E n is equal to minus of lambda t plus log E n0. Right? So drop this and putting it back here implies we get log E n by n0, that is equal to minus of lambda t implies n is equal to n naught e to the power minus lambda t. This is a very important expression. This basically represents the law of radiative disintegration mathematically. So if n naught is the initial number of atoms of the element present, then with time the number of atoms reduces exponentially. So this equation shows that the number of atoms, it reduces exponentially, and the rate of decay, if I consider T over here and N over here, the number of atoms that are present, then it starts with, let me say T is equal to 0, it starts with N naught, it goes down exponentially, and it takes infinite time for a radiative sample. It takes infinite time for the number of atoms of a radiative sample to go to 0. So that makes radioactivity very interesting in a sense. If I have a radiative sample, you can never say that the radiation is 0. You can never be sure. You can never take it as granted that there is no emission from the radioactive substance. Why? Because the activity remains for infinite time. So we have to be careful while dealing with radioactive elements. Also, the slope of this curve, it depends on lambda. And this lambda, the disintegration constant, it is different for different elements, different radioactive elements. It's characteristic of the elements. So this equation, this law is known as Rutherford-Soddy law of radiative disintegration. We call it the Rutherford-Soddy law of radiative disintegration. So that is all for today's lecture. Next lecture will continue from here on. Thank you.